So we saw some interesting looking graphs there when we were graphing the radical functions on Desmos, and we get these graphs that kind of look like this little curve going on up like this. They're not lines. So let's see where those come from. All right. So let's start with our most simple square root function. That's just f of x equals the square root of x. Now remember, this function notation, this is the same as saying y equals the square root of x. So f of x is the same as y. And we're going to graph this. We have our x-axis, we have our y-axis, and we're going to make a table of values. Any equation can be graphed using a table of values. We're going to talk about some shortcuts throughout this course, throughout the next coming lessons. And we'll see how we can use some shortcuts to know where the graph where the graph is. But you can always go back to a table of values. The challenge is if the equation is more complex, you don't know exactly which x's and y's to plug in. So let's plug in 0. And so all we're going to do is we've got y, which is the square root of 0, is 0. And then we've got the square root of 1, which is 1. If you plug in 4, you get the square root of 4, which is 2. Square root of 9, which is 3. Now notice, by the way, I skipped 2 because the square root of 2 is a decimal number. And square root of 3 is a decimal number. So we're choosing or x values that are easy to work with. You can choose, when you're plugging in points, you can choose any x values. The square root of 16 is 4. So we want to choose ones that are nice to work with. So these are points. We have x is 0, y is 0. That's a point on our coordinate graph, 0, 0. And let's see, 1, 2, 3, 4, 5. We should label these with at least a couple numbers. You don't have to write every single number out when you're graphing, by the way. All we need to know is just one number on each axis at least to tell what the scale is. Because we know if I put a 5 there, then that's going by 1, 2, 3, 4, 5. That's good enough. That's acceptable. So, and a lot of times that's better than too many numbers. When x is 1, y is 1. There's a point right here. When x is 4, y is 2. When x is 9, y is 3. And then this graph of 16 and 4, that's x is 16 is off my graph. Okay, now we could plug in 2. When you plug in 2, you get 1.414. The square root of 2 is about 1.414. So that gives us the point 2, 1.4-ish. It's about right here. The square root of 3 is about 1.7. That's somewhere right about here. Okay, so keep in mind when we're graphing these points using a table of values, there's a lot of points. In fact, there's a countless number of points, or actually infinite number of points between any of these two dots. But we just graph a few of them to get an idea of the pattern. So functions have patterns. Okay, they follow patterns. They are a pattern. And the graph shows us the organization of that pattern. It shows us a picture of that pattern. And so graphs are really useful because it helps us understand a function. It helps us understand what happens when the x gets bigger, what happens to the y. Well, here, as x gets bigger, y gets bigger. So we can understand the function and how it behaves for different values of x. What about the cube root of x? All right, so let's go for cube root here. So we've got the cube root of 8. Well, that's 2. The cube root of 1. Well, that's 1. Cube root of 0. Ooh, what about negative numbers? Can we cube root negative numbers? We sure can. Negative 1. And the cube root of 8 is negative 8, sorry. All right. So let's see what that graph looks like. 0, 0. 0, 0, there it is. 1, 1. And let's see, that's 5 there. And 5, 6, 7, 8. 2. So we get the same kind of curve here. Okay. Now, notice, by the way, I should have mentioned this here. Why didn't we plug any negative numbers in there? How about -1? What's the square root of -1? Well, that does not exist. We can't plug in negative numbers. We can't square root negative numbers. So there's no points over here. That's why our square root curve starts at 0 and goes to the right, but it does not go to the left. But our cube root can go. So we have the point -1 can go to the left. -1, -1, and -8, -2. There it is. So we get the same curve kind of going downward here. Right there. So that's the graph of the cube root of x. Okay. And if you graph these on your calculator, you'll see the same pictures. Okay. So the calculator is doing the same thing, just real quickly. Because obviously computers can work a whole lot quicker than we can. So looking at our calculator here, we can say y equals the square root of x, and we'll go to the home view there. There it is. So there's y equals the square root of x, y equals the cube root of x. Got to go to my functions on Desmos. Cube root of x. And there it is there, the blue one. All right. Square root of x in red, cube root of x in blue. Okay. So, all right. Well, what happens if we have fourth roots and fifth roots? Well, we'll investigate that in a moment. But one thing we do notice here is this, that square roots have limited domain and range. It's only part of the graph. It only goes up, only go to the right. But cube roots, this will go on forever, up, 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 even real slow. It's going to go down real slow. You'll eventually get down to -1,000,000 in height. This will actually get up to 1,000,000 in height eventually. So cube roots have no limit in domain and range. So if we have an equation like this, or a question like this, find the domain and range of this cube root. Well, the answer is the domain is going to be from -infinity to infinity, and the range is the same, -infinity to infinity. In other words, all real numbers, because it'll go down forever, it'll go up forever, it'll go left forever and right forever. There's no limit to what you can put in, and there's no limit to what can come out. So odd roots, like third power or fifth power or anything, odd roots will have all real numbers for domain and range.